Here is the 3D model in SolidWorks of the case in transparent, and then the jacks for the banana jacks, and then the internal wiring. And the internal wiring is probably extreme, but it's designed such that the length of the conductors from the jack to each end is identical. So if we trace down this one to the end, this length to the jack is the same as this length to the jack. And then each of these jumpers is exactly identical. These do a circuit in order to keep that length of this coming to the center the same as the ones on the sides. Hide the case here and just look at these. You can see there's not a whole lot of space to get all this in. So that's why we had to do that. And then these are flared on the ends, as you can see, to get a good mechanical wrap around. And then these are also bent around. I'll make a special pliers for those. So you say, okay, that's wonderful, but how on earth are we going to bend the wires to look like that when we've got hundreds of them to make? At least 100 of these and 25 each of these individual, and these four are all different. These four to connect the headers are all the same. So we take the wires that we have here. These are the four that are different. I have it here designed on a block with one on each face, but I actually ended up making them separate blocks, but that's besides the point. So these blocks are, here's the wire. Obviously this flare is not going to be on the end at this moment, but that's the way it's modeled. And these are little flags that can sweep and bend the wire once it's laid in place and bend it to the right angle around the pins. Same way with this one, sweeps around and bends to here, and then stop for the wire when we put it in to get to the right length. And then each individual block has its own design with its wires and what goes in. So we'd start in here like that with the wire inserted to the stop, and then bend, 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 and pop it off. So that's it, four of them. That's the fixture design. So here's the other wire that joins the two headers that are connected to the same jack. This is the 3D model of the wire and the bends that are there, and that's looks crazy, but it's the way that I could get all of them to clear and have good uniform clearance between the conductors. So it starts out with the wire going in here. This does the first bend. Then this one gets inserted, does the second bend at the correct angle. Comes down here, this one will get inserted and it does this bend. And then the top one goes in and it does that bend. Pop everything out and you've got a wire that's bent. So we have 20 gauge wire, 30 thousandths in diameter, that we're using for the internal connections for the banana jacks to the jacks that are in the decade box. So when we take this and we unwind this wire's ripply and got lumps in it and everything. We let it go, we see that it's got a shape and it's got minor undulations. So this is a way of straightening, which basically is just taking the wire, and I'm going to lean on this and I'm going to pull it until the wire actually yields. I'm going to stretch it probably 1/8 of an inch, maybe 3/16 of an inch. So I'm just going to go right there. I just stretched it. Now you can see the wire. Back up so you can see the whole thing right. The wire is straight now. All the kinks are gone. And I'm just going to come in here and nip it off so that I don't put any additional kinks in it. So that's a way to straighten your wires, lengths of wire, so that you get a nice straight wire very quickly. There's no way on earth you could straighten it any better than that. Yes, technically the resistance of this wire is going up because I'm lengthening it, and since I'm straining it axially, I'm also decreasing its diameter. But not enough to matter for what we're doing. And just a little tip that you guys might not be aware of for getting nice straight wire, and then when you go to do your bends and everything on this wire, you're going to be able to have very nice looking bends in your bus bars and stuff, but you're only going to have bends where you want them, not the original rumply wire that we had from off the spool. We have our straightened wire, and we need to cut it to lengths now. So standard strippers, and we use it as a cutter, but they happen to have a nice screw hole they can use. Piece of rod, tapped a hole in the end, standard off-the-shelf clamp collar. Set the distance that I'm after for my wire with the calipers, and then I can just take my strips, take 3 or 4 at a shot, get them lined up, bump up against the edge, and just clip them off, slide, run up against it again, clip it off. So that way you can cut a slew of these things without it precisely to length, without it taking forever. So this is one of the bender blocks for the straps that are, the connectors that are different for each one. This just happens to be number 3. I'm just going to show one because that's all we need to do. Just the steel blocks, dowel pin pressed in. These are 1/16 diameter holes. And then the flag is made from blue tempered spring steel and dowel pin. And then it's silver soldered, soft silver solder, 430°F, stay bright silver solder. This is really good stuff. Harris Stay Bright. It's very handy to have because the flux wets to just about anything, anything but aluminum. So really nice stuff. You can use the regular iron. Don't use this flux on your good electronic tips because this is corrosive. The bottle does not come with a hypodermic needle tip. I took a small syringe, just happened to fit inside the neck of the body, and then put a small stainless needle on, and then a piece of O-ring stock with a hole poked in it to be the stopper, because it's very hard to put the flux on nicely without it drooling all over, and then the bottle gets wet with flux and gets nasty. So if you do get this, if you have the parts laying around to modify the top like that, it'll really be nice. It comes with the I think 3/64 solder, lasts a long time, very handy, especially if you've got stuff like stainless or something that you want to solder to. You can pre-solder, pre-tin with this to get it to wet to, let's say, a stainless connector or something, and then wash it off, get all the flux residue off, and then you can solder to this solder because it's already been tinned with the more active flux without getting the this corrosive flux on your electronic work. So that's the flags. There's different ones for different not purposes, but different clearances, and then there's one to go around the bigger pin. So here's the block. Take a wire, one of these pre-cut blanks that we did before. We take 2 of our flags, one this direction and one the other direction. Zoom in here a little bit more maybe. There we go. And then we simply bend this leg to the line, bend this leg up to the hole, put the next flag in, bend around till we're tangent to this, take this flag out, do our flag that does the radius, and go all the way around, pop them all out. Perfectly bent piece that's ready to go in place and get the ends flared and wrapped. So that's that one. This one is a little more interesting. This one, let me go the direction I'm used to here. This one uses all of the big flag. Piece lays in like that. You have to anticipate the fact that it's going to pull on the first one. This end is going to pull as it wraps a little bit. So we have to anticipate that. And you can see that it comes flush is what's where it should be. Next flag in. We wrap this around till it's tangent. Overbend a little bit for the spring back. Put this one in. Come uphill to the tangent there. Put the last one in. And we bend this one straight. And lined up. And these do line up in a line. So this axis of this one and the one on the tail are supposed to line up. So we just do a visual check there and it looks good. Pop our flags out. And we've got one really nice bent piece that's consistent, that's going to allow me to do these rapid fire when we have to go to assemble these. Keep in mind all these things are based on needing to have fixtures in order to do a consistent product in a reasonable amount of time so that you can do it for a sellable price. So a lot of this fixture stuff, if you were just doing a one-of, yeah, we just get pliers out and make do. But for real high quality and consistency, all these little fixtures, which don't take a huge amount of time if you have a machine shop available, just makes things go better. Here's the $5 pliers from Harbor Freight that I'm using as a basis for my special crimping tools. So whack off the end. I'm going to modify these drill and mill holes in these to receive the hardened steel, high-speed steel insert pieces and braze them in, and these will become the basis of my special crimp pliers. One of the high-speed steel pieces that I've just got done grinding. This is just whacked out of a shank of an old broken tap. I'm using high-speed steel so that when I braze these in with hard silver solder, they'll maintain their hardness because they're high-speed steel maintains the red hardness. So these will not temper and lose their strength when I solder them in. The other nose, this just puts the bend, the J bend in the wire. And then these are the receiving ends of each one. This is just a radius with a bevel, a 60-degree bevel. This does the one that does the flattened wire, where the flattened wire gets bent around the other wire where it's swaged out. So this is also made out of tap, drawing a hole down the center of the tap and then cutting it apart and grinding it. And then the other one is this one. This is for the J-hook wire, where I'm taking the headers and bending them over 180 degrees to wrap around the other connector wire. So just you can see that these are making a special plier just so that I can do a real nice connection that's a mechanical connection first, then solder's just icing on the cake there for electrical conductivity. Here's a shot of the one set of pliers in the mill. It's in the Spindex where I actually ground this nose on there. It's in a collet, so this thing spun, put it in the surface grinder and ground that nose on there. And now I'm indicating the nose end that gets lined up to put the hole in there for the two little high-speed steel insert pieces. So I just wanted you to see the setup for that I'm using to put the hole in there. Here's the setup for the other plier. Same size hole, just opposite orientation, 90 degrees for crimping the flatted ends, just showing the boring operation. There's the pliers ready for heat treat, not heat treat, but silver soldering the pieces in. You can see I've got everything cleared out, and that's the one plier. There's the other one. We've got the the recess is all done and it's relieved, and there's a gap there now. I ground a gap in there so when it's closed, it doesn't silver solder, the pliers shut. Same with this, when it's in the closed position, it'll have an actual gap like that. This is the other plier with the pieces held in. Obviously not silver soldered yet. So the upper piece will get silver soldered to the upper jaw, and the lower piece obviously will get silver soldered to the lower jaw. Okay, all done with the pliers. Here's our J bender for bending the J hooks on the headers. And let me get that here if I can stay in the picture. This goes in sideways like this, and then just puts a J bend in, flip it to the other side, go to this side. This is hard to do in the camera. There we go. So I can get it up close so you can actually see what's going on here. The shoulders on the bottom jaw position it, and then this just closes and forms the J bends on this that are going to crimp around our wires. So that's the one plier for the J bends on the headers. This plier is the one we did for doing the J bend in the 30 thousandths bus wire that we're using to connect everything. And this is a vice grip that's been modified. These are two 10 thousandths thick shims on either side here that control the thickness that it gets squashed to. And the jaws have been ground, I could only hold still probably. Jaws have been ground to be parallel at 10 thousandths. So I just clamp this and put a lock nut on the back here so that it stays put in its setting. And then this bar is for the angle that's on the leads relative to the flat. So I can actually hold a lead in like this, and when I'm doing the lead, I can hold it in place and put the bend on. This lead already has the J bend. Let me get my finger here so I can focus. The J bend on there. I know it was kind of quick. You didn't really get a chance to see much of that. Here's the actual bend on the wire right there. And then I'm going to just show you this plier actually functioning, where I'm going to come in, put the wire in, get my depth in here, squeeze, and now we're flattened. Okay. Then we take this plier and we just put this in location like this, and when we crimp this down, this just does a full bend here. We pop that out and there's our bend. Then we can hook a just get that lined up a little bit better. Then this is just going to simulate the cross wires where they're going to cross and be crimped. Then this plier, these are all just this particular plier is just ground out of a regular plier. This has the hook on the top there, and then the flat on the bottom to close that around there. So if I take this, I can do this without you guys getting seasick from me wiggling all over the place. I just take this wire like this, put this in, and this is our J bend. This is our closer tool. Oh man, it's hard to do. Where this just closes around and actually crimps that shut. So it wraps around and actually pulls the wire in. So now we have a mechanical connection that will solder, but this is really, just a real surefire way to do it, where we've got a mechanical connection. This doesn't even slide in there. That's actually crimped snug, and has a really good bite on it. So that gives us a full wraparound there. That's what this plier does. By having this shape, you can see that it goes in and it actually wraps around, and I can actually come around the top and crimp this so that it's full wrap on there. Get it so you can see better. There you go. So that's not going anywhere. Solder's just icing on the cake here. So all these connections will be surefire, and the solder's just there. Never good to have two wires just crossing each other where the solder joint itself is all that you have. And then same thing here with the these. If I can get in frame here, this will allow me to close these around the wire by using this plier. I can take this around. This isn't actually designed for this lead, but I'll probably do another one for that. But it lets me close those on the jumper wires. I probably need to make a custom one for that. So main concept is, don't be afraid to take your Dremel tool and some grinding wheels and whatever, and modify, you know, these $3, $2 cheapo pliers into whatever you need for, you know, specific application. Here's the jack that's been modified. There's a groove, 30 thousandths wide groove turned in the back for the internal wires that wire this to the header pins, and then the nose has been turned down to 3/16 diameter so that this sits recessed from the inside of the case, and then you'll see the holes, 3/16 holes that are drilled in the case to receive this. So first, the banana jack leads are soldered onto the banana jacks separately. First segment in and soldered. Two in place. 3 installed. You can see the wire clearances here as we go through. Here we're looking at the finished wiring. Vinyl caps installed on the jacks. Here's 2 of them glued into the case. All 4 glued in. What we have here, putting these in, is just a series of pins that goes in to align these in place to get the headers to line up exactly with the pin location. If you found this interesting, please give it a thumbs up and look for other Versa-Ohm construction videos on my channel.